All right, introduction to the atom. Okay, doing this will get you a good start in your packet currently. Now obviously in class we're going to be drawing out atoms and going in much more depth, but I think here we'll give you a good basic idea of how the atom is arranged to start. And this will get you through the packet to get you the idea of the basics. So right here I've got sodium, right here. The atomic number. What you need to know is the atomic number defines the element. In other words, if the element has an atomic number of 2, it's going to be helium regardless. So again, the atomic number defines what the element is. Okay? A student last year, he came up with that saying. It actually is really a good way to remember. So if I have sodium, the atomic number, you find it on your periodic table. It's the whole number. And when you look at the periodic table, you should have one in front of you. The atomic number of sodium is 11. Okay? And you notice up here, these are just conventional atoms. Overall neutral charge. That's the key. Neutral charge, because we're going to talk about, or you would have learned already depending when you're watching this video, protons are found in the nucleus, they're positively charged. Neutrons are found also in the nucleus, they're neutral, no charge. And electrons are around the outside of the nucleus, they're negatively charged, okay? And real quick with that, the bulk of the mass of the atom, right, comes from the proton and neutron. If you think about this, it takes the size of 2,000 electrons, right, to equal the mass of just one proton or neutron, all right? So the atomic number defines the element. So the atomic number is the number of protons. So if I see that I have an atomic number of 11, I know I've got 11 protons. Now, look what it says here. Atoms are neutral, which means that the positively charged protons and the negatively charged electrons, they must be the same in an atom. Okay? So if I have 11 protons, 11 positively charged things, then I need to have how many electrons to cancel that out? 11. Okay? So if I have 11 protons, I've got 11 electrons, excuse me. So now, what is the mass number? We had said before that the mass of the atom, the bulk of it is the protons and neutrons. We will learn about atomic mass and how it relates to isotope and the average atomic mass. But for the mass number, we just take the number of protons and neutrons, where you take the atomic mass and round it to the nearest whole number. So the mass number of sodium rounds up to 23. And we said that that's the protons plus neutrons. So if I already have 11 protons, my mass number is 23 the total, how many neutrons do I have? I have 12. And these are neutral charge, that's why I put a 0 there. So notice what it says up here. Atoms have a neutral charge. Why? The positive protons and the negative electrons cancel each other out, same number. So if I have 11 protons, I have 11 electrons. Okay? But the nucleus is positive. Well, what's in the nucleus? The protons and neutrons. Well, what charge does the neutron contribute? No charge. What charge does the proton contribute? Positive charge. So it's overall just positive. All right, let's go to the next one. Chlorine. So you look at the square. Inside the square on the periodic table, you see information about an element. Some periodic tables show more than others. But in general, you'll see the name, the symbol, the atomic mass, and the atomic number. So if we look at chlorine, it has an atomic number of 17. So right there, that defines the element. So how many protons do we automatically have? 17. Done. And it's an atom in overall neutral charge. So if I have 17 protons, I have to have 17 negative electrons to kind of cancel out to make it neutral. But the mass number, when you take a look at it, when you're doing chlorine, we see that it rounds to 35. So that means I have 35 protons and neutrons. I already have 17. How many more do I need to get? 18. Now again, atoms are neutral. Where does that come from? Same number of protons and electrons. Nucleus is positive. Why? Even though I've got 18 neutrons, they don't contribute a charge. The nucleus has 17 positively charged particles compared to 18 neutrals, so it's still a positively charged nucleus. Okay. let's go down a little bit, and I'm going to do oxygen. And then I'm going to give you a second to pause it, and you're going to do the next two, bromine and aluminum. Again, this isn't hard. So oxygen has an atomic number of 8. And already the atomic number defines what the element is. If you have an atom with 8 protons for atomic number, it's oxygen. If you have an atom with 10 protons, you've got neon. The atomic number, the number of protons, defines who the element is. So the mass number for oxygen rounds up to 16. That's the protons and neutrons. But again, I have atomic number right away. You have the same number of protons. And if it's an atom, it is neutral. So again, same number of electrons. So I have a total of 16 protons and neutrons. I have 8. Obviously, I'm going to have 8 neutrons. Okay? So take a minute, pause the video. And then while you do that, I'm going to go get my answer key so I can just write them up there fast, because I don't feel like looking back and forth between the periodic table. And of course, can't find where my answer key is, so therefore I'll just write it out. It's not that. Alright, so over here, bromine has an atomic number of 35. So when you see that, fill in the protons. Is it an atom? Yes. Right? So if it's an atom, it's going to be neutral, and you're also going to have 35. Bromine's atomic mass number is 80. So right now my protons plus neutrons are 80. I already have 35 protons, 45 neutrons. Again, atoms are neutral and the nucleus is positive. All right, let's go down a little more. Aluminum and nitrogen. Aluminum, 13 is the atomic number. So right off the bat, that means I have, let me double check my columns because I can't see. Okay, so right off the bat I have 13 protons, 13 electrons, okay? The total mass, protons plus neutrons, is 27, 14 neutrons. Atoms are neutral, nucleus is positive. Now, I didn't know. And then last but not least, with nitrogen. Nitrogen, atomic number 7. Right away, 7 protons. It's an atom, 7 electrons. Mass of a nitrogen atom is 14 protons plus neutrons. Therefore, that's 7. Okay? So those are the answers you should have at this point. Now, let's focus on this. Now, ions. Now, it says here are charged particles with a different number of electrons than protons. That's key. Different number of electrons, and add that, than protons. All right, now, so if you take, and I tried to line this up where it's like, okay, you had the sodium atom up here. Now you've got the sodium ion, and the difference is it's got this little plus sign up here. All right, so we're going to talk about that. So again, the atomic number, protons don't change. I said the atomic number, the number of protons defines the element. The atomic number of sodium, regardless, is 11. And regardless, the number of protons is going to be 11. And if you remembered what I said before, the mass of the atom is defined by the number of protons and neutrons. So this is going to stay the same, and it's going to be 23, just like you have up top, and this is going to be 12. Okay? Now, I'm going to change the color so you can see. What makes this an ion? If you look up here, we said atoms are neutral, nucleus is positive, atomic number 11, 11 protons, 11 protons, 11 electrons, neutral, they cancel out. Down here, I have to show a positive 1 charge. Now you got to be careful here. Positive 1 means I've got more protons. That means that, because here's the thing, when you learn pretty soon, electrons are the ones that leave or come in. Okay? They're the ones that move out or come in. The protons stay who they are for an atom of an element. So if we have a positive 1 charge, that means 1 electron left. And so if it's positive 1, if I have 11 protons, that means I've got 10 electrons. So overall, positive 1 charge. I've got 1 more positive, right? If you look at this relationship, right, it's a positive 1 charge because I have 1 more proton than electron. Okay? Chlorine. Again, we showed you the atom up above. Take a look at the data for the atom up above. Right? Here's the data. You already know. This is so important. The atomic number defines what the element is. So right off the bat, the atomic number is the number of protons. That stays the same. The mass stays the same because the mass is primarily based on the number of protons plus neutrons. So again, this is 18. Okay? So now it's got a -1 charge. So I said before, these electrons, they're going to be called valence electrons. They're the ones that leave or come in. So we have -1. That means I have one more negative electron than I did before. So when you look up here, or when you look up top, you saw that you had 17 protons and 17 electrons. But now I have a -1 charge. Because of that, I have 18 electrons. And you notice that leads to a -1 charge. One more electron than positive. One more negative particle than positive particle. Okay? Let's go down to the next one, and then you're going to do, I'll do 2 more, and then you can do the others on your own. Oxygen. Again, it's oxygen. It's 2 negative. We usually put the negative after the 2, the exponent. Or -2, either way, but I like 2 negative. Oxygen. Again, atomic number of protons defines the element. So again, oxygen, right, has an atomic number of 8. Okay? It therefore has protons 8. Okay, number of protons is equal. Now it's at -2 charge. Now hold on. We know the mass is protons plus neutrons. 16, 8. You should know that now. But it's -2 charge. And as I said before, electrons, mainly valence electrons, are the ones that can go or come in depending on what the element is. But that's later. So, if I have a -2 charge, that means I have 2 more negative little things than positives. So that means I have 8 positively charged particles, right? And 10 negatively charged particles leads to a -2 charge, okay? And again, this up here, right? This makes this an ion. Because it's charged. Because if you remember before, we said atoms are neutral. Nucleus is positive. Ions are charged. Why? Different number of electrons than protons. But is the nucleus still positive? Absolutely, because what's inside the nucleus? Just the protons and neutrons. Okay? So atoms are neutral, nucleus is positive. Ions are charged, different number of electrons. Because the protons are the same, defines the element. Okay? So you should be able to do the next 2. And you're going to do it. You can figure that out now at this point. Okay? And I'll just say this, just to give you an idea. All the information here, right? If you notice, I wanted you to see the difference between these things, right? So again, you saw that up top. The atomic number for bromine was 35. Aluminum was 13. I'll double check something. Good. And the atomic number for nitrogen was 7. Okay? And you obviously know everything holds true, right? 535 protons, right? Okay, atomic number. 13 protons, 7 protons. We know the mass of bromine, if I'm not mistaken, is 80, right? The mass of aluminum is 27. Nitrogen is 14. So again, mass is protons plus neutrons. 45, 14, 7. So you see what a neutral atom looks like. We have a -1 charge here for bromine. So if it's a -1 charge, figure out what you have. You have 35 positive protons. Therefore, you should have, fill it in. Think about it. 35 protons, 36 electrons. Okay? Negative, that leads to the -1 charge, 1 more electron. 13 total protons here. Positive 3 charge. Now you learn that aluminum loses 3 in a chemical reaction, valence electrons. So this doesn't change, 13 holds true. Positive 3 means I have 3 more protons than electrons. 10. Giving you the positive 3 charge. You see that right there? And now the opposite here We have nitrogen, right? You'll learn that nitrogen wants to gain 3 valence electrons, okay? Nitrogen wants to gain 3 electrons, okay? So again, when it gains 3 electrons, right, as a negative 3 charge, compare it to the number of protons you have 7. Nitrogen will also have 10 electrons for a negative 3 charge, because you gain 3, okay? All right, so now, isotopes, different forms of an atom. We'll spend more time in class on these. Oops, excuse me. Now these are a little different, but not too much. Look at the 3 carbons. Now, we're going to, isotopes we spend a lot of time on. Yeah, I'm not going to use this now. Isotopes we spend a lot of time on. Different forms of the same element with a different number of neutrons. Okay, so let's go back to the key, the foundation. Atomic number defines what the element is. Carbon, carbon, carbon. Carbon, 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 the same thing. Now these are atoms. Different forms of atoms with different number of neutrons. So watch this, we call them isotopes. It depends on their abundancy. And we'll get into average atomic mass. We'll get into that, okay? But let's get the basic idea. This 12 right here, 13, 14, that gives me the mass. And you're going to learn that carbon 12 is much more abundant in common on Earth than 13 and 14. That's where we get into percent abundance. So let's just get the basic idea. The atomic number for each of them, if you look on the periodic table, 6 protons, 6 protons, 6 protons. Why? The atomic number defines the element. 6 protons. And again, 6 protons, 6 protons, 6 protons. Now these are still different forms of an atom. So they are neutral, still. So again, electrons, same, whoops, electrons are going to be the same. 6, 6, 6. Now, mass number, here it is. Look, let me color it in so you can see it really well. That is what varies. 12, 13, 14. Now, we already said the bulk of the mass comes from the nucleus, which is still positively charged, the positive protons and neutral neutrons. So I've got carbon 12. That's the most abundant form. Okay? So the mass number is 12. So I have 6 protons. I got 6 neutrons. 6 plus 6 gives you the 12. Over here, I got carbon 13, which is it's rare. I've got 6 protons. My mass number is 13. Therefore, I've got 7. 7 neutrons, and that leads to mass number 13. And then carbon 14 over here, 8, and that leads to 14, 8 plus 6. Most abundant, which we'll talk about, less abundant, significantly less abundant. And when you see that it's 12.011, this right here you'll learn contributes to that 0.011 with the average atomic mass. And then boron 10 and 11, we know boron has 5 protons. And that's its atomic number. Let me make sure I'm lining it up right. Oops. 5 and 5. Atoms are neutral, nucleus is positive, same thing. What's the difference going to be? This is boron 10, this is boron 11. Boron 10 has a mass of 10, boron 11 has a mass of 11. So you'll notice that boron, just to give you a preview, has an atomic mass of 10.811. Which tells us, right, we round this up to 11. But if you look here, this is the average of all the borons in the world. So you could, by looking at this, see that, wow, there must be more boron 11s than 10. So since we're closer to 11, there's about 80 to 81% of all the boron in the world is boron 11. The remainder is boron 10. Okay, so they vary a bit. So this right here, right, if you take a look, the mass is 10. 5 protons, 5 neutrons. Mass is 11, 5 protons, 6 neutrons. So you see how that works. This part here in percent abundance and in-depth concept of isotope we'll get into. But again, by going over this, you guys should have a pretty good comfort level going into this packing so we can move forward in chemistry. All right, make sure it gets done. That's it. Introduction to the atom. Get it done. All right. Good job.